Alright guys, we're going to take a look at exponent rules. Now this is the basics of what we're going to get ready to do, so please, alright, pay attention and make sure you're watching and listening to the video. So let's take a look at zero exponents. Okay, take a look at zero exponents. Anything raised to a zero power is always equal to 1. Anything raised to a zero power is always equal to 1. This is a listening check. Underline the word 0. This is a listening check. Underline the word 0.
Keep it real, we bubbling. Who are you to be judging? Money flip Gabby Douglas. If you ain't clean, you bugging. Every single day, people always ask me how I live this life and how I stay so clean. This is what I tell them. It ain't about my jeans.
One more time. Anything raised to a zero power is always equal to 1. Anything but 0 actually. Alright, so let's take a look at an example. Let's say what's 2 raised to the power of 0. Because it is raised to the power of 0, it is equal to 1. Take a look at another example. 256 raised to the power of 0. Because it is raised to 0, it is equal to 1. Let's say that instead of numbers they had variables. So let's say you had x raised to the power of 0. Again, doesn't matter what it is always going to be equal to 1. Take a look at one more example. 100,000 raised to 0 is going to be equal to 1. So you get the idea. Everything raised to the power of 0 is equal to 1. But be mindful, okay? Be mindful. Negative 356 raised to the 0 power is not equal to 1 because the exponent is always attached to just the number or the thing right in front of it. Okay, so that means you can imagine an invisible parenthesis. So that negative is outside. Then anything raised to 0 is 1, but the negative is outside. So this is actually equal to negative 1. So do remember that anything raised to a power is always attached to what's right before it, unless they're parentheses. So just be careful of that. But anything raised to 0 is equal to 1. Just keep in mind that this negative is not attached to the 356. Alright, so let's take a look at negative exponents. Exponents raised to a negative power can be rewritten as positive powers by taking the reciprocal. Again, exponents raised to negative powers can be rewritten as positive powers by taking the reciprocal. Exponents raised to negative powers can be rewritten as positive powers by taking the reciprocal. This is a listening check. Color in the word positive. Color in the word positive.
I always gotta be clean. G's a beast in fashion. I'm swagging on the scene. It's a dirty world, so you know I gotta be clean.
You know I got to stay clean. Tryna live this life, no shame. I'm ballin' like Kareem, and I'm geeked up, no caffeine.
So what does that mean? Well, let's take a look at an example. Let's say you had 2 raised to the power of negative 3. So that's a negative power. A negative power can be rewritten as a positive power by taking the reciprocal. So we can write that as 1 over 2 raised to the positive 3. So that's all it means.
So
all you need to remember is if it's on the top, it goes to the bottom. If it's on the top, it goes to the bottom. If it's on the top, it goes to the bottom. So let's look at another example. 100 to the negative 4. Again, write the reciprocal. It's going to go to the bottom because it's at the top. So it's 1 over 100 to the positive 4. But let's take a look at the flip side of that. What happens if it's already at the bottom? So the top goes to the bottom and the bottom goes to the top. The bottom goes to the top. Alright, so let's take a look at an example of that. This is a listening check. Put a circle around the word and. Put a circle around the word and. So let's say you had 1 over 3 raised to the negative 4. It's at the bottom. So all you're going to do is take the reciprocal, which means it goes to the top and it changes to a positive. So now it's 3 to the positive 4. Take a look at another example. Let's say it's 1 over 5 raised to the negative 8. 1 over 5 raised to the negative 8. It's at the bottom, so you're going to take it to the top. You're going to change the sign. That's all you're going to do really, is change the sign when it crosses a fraction bar. So it's now 5 raised to the 8. So the top goes to the bottom and the bottom goes to the top. Alright, now once you're able to do this, they're not going to stop at that. They're going to ask you to actually evaluate these exponents. So I'm going to take a look at a couple of examples of us evaluating. So let's say, for example, I had 4 raised to the negative 2. Well, remember that's already on the top, so we're going to take that to the bottom. So it's going to be 1 over 4 squared. Well, what's 4 squared? It's 16, so it's going to be 1 over 16. And that's really all there is to it, okay? So it's not really very difficult. Let's take a look at another example. Let's say we had 1 over 3 to the negative 3. 1 over 3 raised to the negative 3. And again, because it is at the bottom, we're going to take the reciprocal so we can make it positive. And by taking the reciprocal, it's going to go to the top and change signs. So now it's going to be 3 raised to the power of 3. Well, what's 3 raised to the power of 3? 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So your answer is 27, and that's all it means by evaluate. Alright, let's take a look at another rule. This is going to be the product rule. Okay, with the product rule, it must have the same base. And what you need to know about the exponents is you add them. It must have the same base, and you add the exponents. You can actually go ahead and write in, you add the exponents. This is me checking if you're listening. You're going to write there, you add the exponents. Alright, so looking at the first question, 2 to raise to the 5th power times 2 raised to the 3rd power. Well, what's 2 to the 5? It's 2 5 times. What's 2 to the 3? It's 2 3 times. How many 2's total are there? There are 8 of them. Well, that's how you do it old school, but now using this rule, you can actually shortcut it a little bit. So we can actually use the rule in order to do it. So all you have to do is you're going to add the exponents. You've got 2 to the 5 times 2 to the 3. You just want to add the exponents, which is 5 plus 3, which is equal to 2 to the 8. We get there a lot faster than writing it all out. So from now on, we're just going to do the rule. So let's look at another example. Let's say you had x raised to the 3rd power times x to the negative 2. Again, because it's multiplication, it's a product rule, all you're going to do is add them. So 3 plus negative 2 is 1. So what is x to the 1 power? It's just x, because it's only one of them. Alright, let's take a look at another example. Let's make it a little bit more complicated this time. So the product rule is when you're multiplying, you just add the exponents. Number 3. So remember they had to have the same base. So you see a and a go together. So now those exponents, you're going to add them. You'll say 3 plus 2. And then b is by itself, so b squared. So a is 3 plus 2 is 5, and then you have b squared. I can't simplify that anymore, so that's my final answer. So you just have to make sure the bases are the same. Number 4, let's say we had x squared, y cubed, z, y5, z2, x to the negative 1. Just pause and copy. As a listening check, put a box around question 4. Alright, so again, we have to have the same bases. So I'll start with the x. So find another x. See, there's x to the 2, x to the minus 1. What do? You add them together. 2 plus negative 1. Y is plus the other 5, so 3 plus 5. Z is invisible 1, and the other one, which is 2. So 1 plus 2. And there's nothing else. So now we're just going to simplify that. We're going to get x to the 1 power, y to the 8th power, z to the 3rd power. I'm just going to rewrite that because it's an invisible 1. So x, y to the 8th, z to the 3. So remember the product rule, you add. So let's take a look at the quotient rule. So the quotient is opposite of whatever the product is. So if you're adding with the product rule, obviously with the quotient rule, you are going to subtract. So again, it must have the same base and you subtract. Again, for me to check if you're listening, right underneath subtract, you're going to say you subtract the exponents. You subtract the exponents. You subtract the exponents. So look at an example, 5 to the 3rd power of 5 over 2. Well, let's do this without the rule. You just multiply it out. And again, remember, if you have the same number on top as you do on the bottom, you can cross them out. So this simplifies to just 5. Alright, so let's take a look at how you would use a rule. Alright, so remember they have to have the same base, and it's a quotient, and you subtract. So we're going to have 5 over 3 over 5 over 2. It's a quotient, so you subtract. You're going to subtract 3 minus 2. And what are you going to get? 5 to the 1, which is invisible 1, which is just 5. So it gives you the same thing. Again, from now on, I'm just going to use the rule. So c to the 5 and c to the 8, we're going to subtract again because it's quotient. So c, 5 minus 8, which is going to give you negative 3. And they usually want to see the answers in positive. So remember, if you have a negative exponent, what do? You can go back to your notes if you forgot what this is. Negative exponent. And it just says if you just find the reciprocal. Okay, so negative becomes positive by the reciprocal. Top goes to bottom and bottom goes to the top. So in our example, we have the top, so it goes to the bottom and it becomes positive, 1 over c3. Alright, let's take a look at a more complicated example. This is a listening check. Color in question 3, the number 3. Alright, so we've got, again, quotient. We've got a mixture of quotient and product here. So look, at the x's, we've got a quotient, so it's going to be 4 minus 2 because quotient is subtract. With the y's by itself, so nothing. With the z's, you've got a quotient, so it subtract 1 minus 1. Simplify that. What's 4 minus 2 on the x is going to give you x squared. Y squared is by itself, so that's y squared. And then z, 1 minus 1 is 0. Oh, wait a minute. Something is raised to the 0 power. Let me go back in my notes and see what that is. 0 exponents is always equal to 1. So that means z to the 0 is equal to 1. Perfect. Simplify that because anything times 1 is just is whatever it is. So x squared, y squared. Let's take a look at one final example. Again, you see the 2's, so the bases are the same, so we're going to subtract that. So before I subtract, because I've seen that there's a negative exponent, let me go back to my notes, look at a negative exponent, see what I should do with the negative exponent. Okay, so take the reciprocal, bottom goes to the top, top goes to the bottom, this one's at the bottom. So we're going to take that to the top. When you take it to the top, it becomes positive, just like that. I'm just going to go ahead and rewrite everything else as it is so it doesn't confuse you. So 3 squared over 1, 3, and remember we took that 2 to the top, so just 3 to the 1, invisible 1. So now again, we've got product rule because we're multiplying, we're not dividing. So product rule says that you add. So you see the two 2's, the base of the two 2's, we're going to add that. So 3 plus 2 on the exponents. Then the 3's, the quotient rule. So again, we're going to subtract. So it's 3, 2 minus 1, and then 1 over 3. So let's go ahead and evaluate that. 3 plus 2 is 5, 2 minus 1 is 1, and 1 to the third is 1 to the third. Let's simplify that. 2 to the 5th power is 2 times 2 times 2 times 2, 5 times basically, times 1, 3, and then times 1 times 1 times 1. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32 times 3, that I got to work out. So I'm going to get 96 divided by 1, because 1 times 1 times 1 is 1, so it's equal to 96. This is a listening check, color in 96. Alright, so let's take a look at a power rule. And again, you're getting the hang of it. With exponents, before you can combine any two exponents, the bases have to be the same. So again, must have the same base, and you multiply. And your listening check here is you are writing underneath multiply the exponents. So you multiply the exponents. Make sure you write that down for you to get full marks. Multiply the exponents. So here's an example. Something raised to the power. Normally it would have been x times x and then 3 times. So 3 times of x times x. So x times x, x times x, x times x. And how many x's total is that? That's x to the 6th power. But again, the rule makes it shorter. Okay, so with the rule, all it is if it's a power rule, you just multiply the exponents. So if you have x squared raised to the power of 3, then just multiply the exponents. This is a listening check, color in the word or, which is going to be 2 times 3, which is 6, x to the 6th power. We get that a lot faster than doing all of that. So basically, it's really good for you to know the rules. Let's take a look at another example. What if you had 3 cubed all squared? Again, you're just multiplying the exponents. So it's going to be 3 to the 3 times 2, which is 3 to the 6th power, which is 3 times 3 times 3 times 3 is 6 times. So 3 times 3 is 9, times 3 is 27, 27 times 3 is 81, 81 times 3 is 243, 243 times 3 is 729. Again, I'm just doing this without a calculator, which you will have to do without a calculator as well. Alright, take a look at another example. So if you have 2x squared, remember you're going to square everything. So to get in the house, you're going to square everything. It's 2 squared and then x squared squared. Which again, because it's the power rule, you multiply the power. So 1 times 2 is 2, 2 times 2 is 4. So you're going to have 2 times 2 and then x 4 times, which is 4x to the 4th power. This is a listening check, put a box and color in that answer. Right. Another example, last one. So say you had 3 to the 11th power raised to 0. Okay, again, put it into the house, or put it into the house because it's all individual. It's going to be 3 to the 0 power and then x 11 times 0. So that gives me 3 to the 0 and the x to the 0. Oh, look at that, something raised to the 0 power. What happens when you raise an exponent to a 0 power? It's always equal to 1. So 3 to the 0 is 1, x to the 0 is also 1, so 1 times 1 is 1.